Hello. In this video, I'm going to demonstrate the use of variables and data types in Java. Let us begin by creating a project. I'll give the name of the project as using variables. Let us also create a class which acts as a program. So I'll call it as program01 in a package called code.vinod. Let's also add a main function. A variable stores values. So I can just take something like num equals to 10. Now note that I cannot just take a value and assign to a variable. It has to be declared. If I move the mouse on the error, it says that num cannot be resolved to a variable. It says create a variable called num. So I have to first create this num, then I can assign. Now to create a variable, I must use a data type. Now there are two types of variables in Java. One is a variable of a specific data type called primitives, and the other one is called references. First, let's look at primitives. Now, primitives are made up of one of these types. So there is byte, short, int, long. These are integers. There are floats and double acting as real. And there is Boolean and characters. So these are the 8 primitives that you can use for declaring this. Now, it depends on what kind of value you are storing, based on which you will choose an appropriate type. Imagine you want to store some number, so I'll just declare this as int num. Now you can see that the error is vanished. Now it also gives me a warning that says that, hey, you have declared variable called num. You might have even initialized, but it says that it has never been utilized. So let us just utilize it by using a sysout. And now note that in the system.out.println, I can use num equals to and a plus symbol to concatenate that value. So Java has a built-in mechanism to concatenate anything as a string. For example, num equals to here is a string, and this num is a value which is equals to 10. So if I execute this now, you will see that it is going to give you the num equals to 10 as the value, as the output. So I see that over here. Now, how much value you can store in a variable depends on the number of bytes that are assigned for each one of these. Now, byte is a 1 byte location, short is for 2 bytes, 4 bytes, 8 bytes. Now, that's the maximum storage available for numbers. You also have float and double, which are for decimals. Float is 4 bytes, double is 8 bytes. Now, Boolean just stores a flag, and ideally it is a 1-bit storage, is to store either it is a true or false, and char is given 2 bytes. So because there is a limitation, if you store any arbitrary value which exceeds the actual limit, you will get an error. For example, I'll say num equals to, and I'll give a very big number and put a semicolon. You can see that compiler is already telling me that, hey, the literal so and so big number is out of range. So it would be a good idea to see what is the range for each one of them. Now, for each of these primitives, there is a specific class in java.lang package, which is called as a wrapper class. So a wrapper for each of them in the respective sequence is byte, short, integer, long, float, double, boolean, and character. So these are the classes that represent these data types. So these classes have specific information that will help us to identify how much or what is the range of values that we can store. So if I really want to know what is the range of values in each one of them, I can use this approach. I can print out saying that the max value in a byte variable is, and then I can type byte dot max value. Now note that max value is a field available in this class that is public, so that I can access this and I can print that. Similarly, I can just use a min value in a byte variable is, and then I can print on the same lines byte dot min value. So if I save it and execute this, I should see that it says maximum is 127, minimum is minus 128, and you try to go beyond this range, the compiler will warn you. So let's see what is the biggest integer that we can store. So let's go and say sysout max value of a long variable can be plus long max value. And of course, I can copy this and paste it, change this to min, and of course, I can change this to min as well. So execute it. Now note that this time I'm not saving the file, but I'll execute straight away. And it will ask you that, hey, save and launch. Now select resources to save. And it says that this file has not been saved, so you might want to save it. Otherwise, it will execute the previous version of the compiled code. Now I can also say always save resources before launching. I'll say OK. And now you can see this is the biggest value that I can store. Now it's very hard to say how big is this or what is this, but it's quite a big number. Now if you really want to go beyond this, then you can consider using double. Now when you're working with integers, it is a good idea to use int rather than any other smaller data types like byte or short. Now you might think that you want to save some space, but compilers are optimized for using int as far as integer is concerned, and double as far as float or real type is concerned. For example, if I use here a float f or f1, and then if I type f1 equals to 1.0 and put a semicolon, you can see that I'm getting an error. Now that is because compiler is treating this as a double, so that's going to be 8 bytes, and you're trying to store that 8-byte value in a 4-byte location. So it is basically saying that there is a type mismatch, cannot convert from double to float. So it's assuming that this is double. So this is one of the evident factor that that says that double is preferred than float. However, if you really think that I want to use a float, so you can always suffix this with f small letter or capital letter, and that will make it as a float. And of course, you can always print it like this, f1 equals to plus f. Now you can also store, you can also assign in the exponential format. For example, I can say double d equals to, and then I can type 1.234, whatever the number that I want, and then I say e minus 49, and that is okay. When I want, I can also print that d equals to plus d, and you will see that it just gets printed in some appropriate format. So let's execute this, and you can see it's printing in the similar format. So this is how you can use variables and data types. Before we conclude, let us also see how booleans can be used. A boolean, unlike the numerical types, take only two constant literals called true or false. So I can say boolean and I can say tf equals to true, or I can say tf equals to false, and then I can print something like tf equals to tf, or I can even say not of tf equals to plus not of tf, and that actually complements the current value and prints it. Let's execute and check that out, and you can see it's printing in this format. Now we'll also look at a character. A character is basically going to be 2 bytes. Now you can't assign a number, like for example character ch. If you say ch equals to 100, now you can see that it is okay. We can just type here ch equals to ch. It doesn't print 100 because when you retrieve the value back, it's going to convert that 100 into its Unicode equivalent. Now 0 to 255 is the same as ASCII characters. So since this represents an ASCII character D, the result is going to be D. So you can see that it's going to be D here. So with this, we have reached the end of this particular demonstration. So where we discussed about variables and data types.